Morning po, sir.
Okay, group 3, lead us in prayer. Anybody from group 3? Can you hear me, group 3? Narinig ba ako ng group 3? Can you hear
Naririnig ka
me?
naman po, sir.
How about them? Group 3, where are you? So I need to mention the names of the group 3. Maybe they're not really remembering their group mates. So who are the members of group 3? Okay, they are the following. I hope it's Francisco Gagasa, Mendoza, Esma, Garciano, Gudis, and Guevara. 2, 4, 6, 7. So among those 7 students, are they around? Narinig ba si Sir? O delay?
Naririnig po.
Okay. So I mentioned all the names of the group 3. So let us pray. Close your eyes and bow your head. I will be the one to pray. Heavenly Father, thank you very much for this wonderful day. Thank you for another day for the students of Great and Galileo so that they can learn things in Mathematics 10 as we go along with the discussion. Give them enthusiasm, give them interest, and give them the encouragement to really understand all the topics that we're going to discuss. And I pray that you will give us the peace and the harmony that we need in order to understand all things. We ask this in Jesus' name we pray. Amen. Okay. So, good morning. Welcome to our second quarter, week 1. For the information of everybody, so this LMS is still doing some maintenance with the week number 1 because there's no gap between first quarter and second quarter according to the instruction last week. So, we will push through with the second quarter, but since there are some technical difficulties in fixing the LMS, so that's why your LMS week 1 will be extended until next week. So may I don't know what date. So we will have the extension, it maybe Thursday also. Okay. So today, so for the LMS week 1, so I'm going to present first. So let's proceed without further ado. So this is the week number 1 for second quarter. Okay. This is just to remind you that since your adjustment period is last first quarter, so today, so I'm going to really have the application for the SSC since I'm doing that since last year. For every synchronous class, you will have a Google Classroom output. So maybe there's an equivalent learning task. So sometimes I'm removing two or one or two learning tasks to equate the required synchronous class output. So that could be in Google Classroom. And then your final requirement. So in replacement of some learning tasks, you will present a video. You are the one teaching and explaining some examples of polynomial functions, applying fundamental theorem of algebra, applying Descartes' rule of sign, and applying rational root zero theorem, and then the generalization or the conclusion about the answers with the given problem. So it's up to you. I will give you a problem, and then you will be the one to solve it, having a video, so you can use the whiteboard, you can use the monitor. It's up to you. So I will give you examples next week so that you will have an idea for the final requirement for the second quarter. So maybe you will have that in 1 month. I'm going to give you 1 month grace period or period in order for you to complete that task. But I'm going to give you an assigned problem for polynomial function. So expect that the degree is much higher than 3. So we will start from quartic. Then you will apply the fundamental theorem of algebra, Descartes' rule of sign, and the rational root theorem. So yesterday, do we have class? Yes, last week. Rudil, do we have class last week? We don't have synchronous last week. Do we have?
Wala po, sir.
Okay. So, last week, maybe I'm experiencing, I hope that I'm feeling well right now, but there are still some quote unquote mark of not feeling well, but nevertheless, we have to continue. Okay. So, since last week, so there's some topics in LMS. So, it's all about the polynomial functions, naming polynomial functions according to degree, and then applying the fundamental theorem of algebra, the Descartes rule of sign, and the rational root theorem. Studying all the resources in LMS uh, with regards to your score. So maybe I can really assess that you know already all the things that you need to apply in an equation. So the main focus for today is all about the function. But I want to check if you really adapt or acquired things with regards to polynomial equation. So the application of fundamental theorem of algebra. How are you going to apply fundamental theorem of algebra in an equation? Descartes' rule of sign and rational root theorem. Let's start with the fundamental theorem of algebra. What is that all about?
Yung paggamit po ata yan, sir, ng additional property of equality tas multiplication property of equality para ma-solve ang value ng is topic?
That is the fundamental theorem of algebra.
I guess,
So,
sir.
okay. Any other idea about the fundamental theorem of algebra? Say, for example, we have a given equation that is x cubed plus 3x squared plus 2x is equal to 0. So how are you going to apply the fundamental theorem of algebra? So it seems that your answer in LMS are really good. So I just want to check if you really uh, understand the topic last week. Okay, so let's have first it.
Sir, what
So
again is the fundamental theorem of algebra?
so I'm just asking you if you really applied the fundamental theorem of algebra. Did you? No.
I think so, but ano po, sir, yung fundamental theorem of algebra?
It means you don't have any idea about the fundamental theorem.
Maybe not the name.
Oh, okay. But in LMS you don't have any. I didn't have the PowerPoint submitted to your FB group. So your section doesn't have any copy of the PowerPoint for week number 8, right? Because we don't have any synchronous class. Okay, so sorry I didn't post the PowerPoint for week number 8. Okay, so maybe since you don't have any idea about the fundamental theorem of algebra and then Descartes' rule of sign and the rational root theorem, so we will apply that also in function, right? Because it is also related. Because an equation can be a function, right? but not all equations are functions, right? Okay, so we will proceed. So along the way, we can discuss those terms that you need to apply in the polynomial functions. Okay, let us um, have it. Okay, and then so let's try to match this PowerPoint slide with your Google Meet. Okay, so I don't need to have the uh, time to time question about the fundamental theorem of later. Okay, so the main focus for this week, okay, illustrates polynomial functions, understand, describe, and interpret the graph's polynomial functions. So learning task 1.1, 1.2, 1.3, 1.4. So last week, so the main focus is the application of fundamental theorem of algebra, Descartes' rule of sign, and the rational root theorem. And you can solve for the roots using the remainder theorem and using the synthetic division and the factor theorem in order for you to determine the roots of the given equation, right? Because in a polynomial equation, so we can say that the polynomial equation is in standard form. So if we just have the okay, if we simplified all the terms and then the order is descending, so from highest to lowest exponent, that is the standard form. And there's also a factored form. So one of the requirements in order for you to solve for the roots, you must express your polynomial equation to factored form. Because if you already express your polynomial equation to factored form, it's very easy for you to solve for the roots because you are just equating or applying the zero product property, right? So by equating all the factors, you can solve for all the roots. So that's the main topic. You can use synthetic division, you can use remainder theorem to solve for the roots. So it's a case-to-case basis. And also there are cases that you just need to apply some process of factoring. If you have four terms, you can use factoring by grouping. If you can solve for the values of x with that given polynomial equation, that's it. It's okay. But since in polynomial equation, so if we're applying the synthetic division, we always stop when the depressed equation is in quadratic form. So I hope that you have the idea about the depressed equation. Depressed equation is the other equation that we can get after having the performing the first step of synthetic division. So say just like dividing polynomials. So when we are dividing polynomials, if we want to get quotient, all we have to do is to annex the uh, term. Okay, if the given is too big, so you just subtract one. So the quotient is x squared. So that's the essence last time with the division of polynomial. But in using synthetic division, so we have what we call depressed equation. Depressed equation, we can see that after performing the synthetic division, right? And then we can still continue. But if you reach already the quadratic, don't it's up to you to continue using synthetic division. But if when you reach quadratic equation as your depressed equation, so you may use factoring, you may use computing the square, you may use quadratic formula, right? So those are the things that you can use if the depressed equation is in quadratic form already. But if it's still in cubic, you can still use the synthetic division. Okay. So since we will just discuss those what I'm discussing, the fundamental Descartes and the rational root. Okay. So let us have this first. All functions are relations, but not all relations are functions. Okay, that is very quote unquote kung baga sa kasabihan ni Rizal, the sayings of Rizal, ang hindi magmahal sa sariling wika ay higit pang amoy sa malansang isda, or ang hindi limingon sa paroroonan sa pinanggalingan ay hindi makarating sa paroroonan, so on and so forth. But in mathematics, especially in grade 10, this is a very quote unquote palasak term. All functions are relations, but not all relations are functions. Any idea? What about with this statement? How can we say if a given relation is a function or not, di ba? Not all relation has can be we cannot say that all relations can be a functions, but all functions are relation, right? So, nag-uumpisa sa relasyon at may patutunguhan. May mga bagay na walang patutunguhan. Pag may mga bagay na walang patutunguhan, relasyon lang yon. Pero kung may patutunguhan, there is a function. Sa buhay natin, if we're going to apply it, medyo sensitive pag nag-apply tayo sa maraming relasyon, di ba? We have different kinds of relations right now, di ba? Accepted by the world. Before, ang accepted lang male to female, right? But nowadays, it's accepted that we can have male to male, female to female, so on and so forth. There are so many descriptions of our gender. So the world is still accepting that. But during or before, so it's not accepted by the society. But now, the if you're going to say anything against those having relationship with the same sex, you will be bashed and you will experience things that you don't want to experience. So just like here in mathematics, there are cases that some relations doesn't have any functions. So how can we say if the given relation has its function, or can be said that it is a function? It's a function. So vice versa. Let us examine first what is a relation. So I don't need to ask you anymore. During your grade 7, grade 8, you already differentiate functions and relations, right? Natandaan, napakarami. We can use so many things to differentiate relations and functions. Okay? So what is that all about? So that we can have, I'm just having this slide. Yan, set of ordered pairs. And then we have that set of all second coordinates. And the y is the relation and so forth. The domain and the range, you are used to that. Your domain is your input and your output is your range, right? And then how to represent the relations, we have this table of values, mapping, and graph. If you're going to observe the relations, so there are cases that there are some observations of really expressing the relations. We have three ways of representing or representation of relations. Table of values, mapping diamond, graph. And then we have kinds of relations. So sometimes they call it, another term for relation is correspondence, right? One-to-one correspondence, one-to-many, many-to-one. Okay. So all those things we can use just to differentiate function. Okay. So is one-to-one relation can be considered a function? Yes or no? Yes. How about one-to-many?
No.
Cannot be. About many-to-one? Okay, Rodin, many-to-one?
Pwede po, sir.
Pwede, okay. Therefore, upon observing that, or with that correspondence of relations, so with the values of x, with the values of y, we can have the answer. So what is the definition of a function with regards to the values of x and y? Dapat ano, Rodil? So what must be your definition of a function now?
Whenever a relation, whenever in a relation there is only for every one x, there is only one y, that is a function.
Okay, so the domain, if you just have one domain, you must have one range only. But if you have two or more, or there's possibility, it could not be, right? So that's one definition, and that's it. Try to read. Okay? Okay. So, and in a layman's term, quote unquote, we don't have any repetition of our domain, right? If there's repetition of domain with regards to ordered pairs kasi to, so if there's a repetition with the values of x, it's not a function. It's just mere relation, right? But if there's a one-to-one correspondence for every domain, there is exactly one range. We can call that as a function. So if the ordered pairs or the mapping is given. Okay, one-to-one and many-to-one. Okay, So all you have to do is to remember if doesn't have any repetition with the values of x, therefore that is a function or one-to-one correspondence. For every values of x, there is always a corresponding value of y. If that is the case, therefore we can say that the relation is a function. I hope na-discuss nyo na naman yan. Review lang konti. Medyo magpo-focus lang si sir dito ha. Tawag tayo ha. Tingnan natin. Okay. Number 1, Cervantes. Is number 1 a function or not? So we have 8 equations given. Do you have that during grade 9? Given equation, then you have to identify if that equation is a function or not.
Noong grade 8 po, sir.
Grade 8. Okay. Bigyan mo nga ng sample number 1, Rudil. Is it a
Number
function or not?
1, this one is a function.
Yes.
Linear
Why?
function.
Yung reason mo kanina.
Kasi kung papansinin mo, sa pag-substitute mo ng isang value ng x dito, isa lang po yung mapapalabas mo na y.
Okay. So ganun lang ha. Simplihan lang natin. Out number 2. Anybody? Kayo ba yung magkakaklase ng grade 8 and grade 9, Rodil? All of you? You belong to one section, right?
Yes po, sir.
Okay. Your teacher in grade 8 is Ma'am Donna, right? And then grade 9, Ma'am Velasco. Okay. I think grade 7 is Ma'am Luna. Right? Ma'am Luna, Ma'am Donna, and Ma'am Velasco. Okay. So how about the others? What's your idea about number 2? Anybody from the Galileo? Is it a function or not? Na-discuss ito ha, Rodil ha, nung kayo ay grade 8. Napaliwanag naman yan sa inyo if you have an equation and then identify whether it's a function or not. Maraming way dyan, di ba?
Somehow po, Papiaw.
Oo, sometimes ini-interchange natin yung x and y, di ba, no? And meron tayong mga case na gagawin dyan. And then, but here, it's just a shortcut method ang gagawin natin. So, i-check lang natin if there's one-to-one correspondence with the value of x and y, that's a function. With number 2, is there possibility that we can have more values for y in number 2? Yes or no?
Sir, ano po yung question?
Is there any possibilities that we can have more values for y in number 2 given here? The given is y is equal to x is equal to y to the fourth. In order for us to identify whether that equation is a function or not, is there any possibility that we can have more values for y here in number 2? So it means that we can have the fourth root of x. Rodil, yes.
Sir, posible po.
Yes, so
Posible
we can
po
have...
magkaroon ng dalawang values for y kung sa isang value ng x.
Okay, so ganun lang yung ano natin. So ang check na lang dyan, generalization, just check all the exponent of y. If the exponent of y is even, therefore, so that is not a function. If the exponent of y is odd, that's a function. Yun yung isa ha. And then if you want, you can use the table of values. If you can use table of values and then you can have two or more values for y, that is not a function. Review lang yan ha. Sige na, baka tayo umabot pa dyan ng 10-10. Okay. So for every one output, so polynomial. Okay, so still we have this definition of polynomial. So we can say that the given expression is polynomial if it satisfies the following restrictions. Okay, and then we have this polynomial. Of course, we have the leading coefficient, leading term, terms, and constant. So this is what we call the standard form of polynomial function. Sometimes they use F to represent functions, but you can still use all the alphabets, right? You can still use A of X, B of X, it doesn't matter. But in mathematics, they always represent, in order to be closer to the word function, they use F. But with regards to P of X, that we call polynomial of X, function of polynomial of X, or function of P of X. But most of the time we use F of X. So that is a standard form, okay? And of course, the degree of the polynomial is the largest power of X exponent, so we don't need to have that question. Okay, and then we name again, just like the quadratic equation, we name the quadratic equation by, paano natin pinapangalanan ng ang ating mga polynomial equation? By its, Rodil? Paano
By its degree.
pinapangalanan? Okay, by
Degree,
its
highest
degree.
exponent niya.
Okay, it's the degree or the highest exponent of all the terms. Now, so if we have three terms, just check the degree of all the terms, and then whatever the highest degree, that could be the degree of the polynomial, and that could be our basis to name a polynomial equation. If the highest degree is 1, we call that equation as, if the highest degree is 1, we call that equation as linear, right? 2 quadratic, 3 cubic, 4 quartic, 5 quintic, 6 degree equation, 7 degree equation, so on and so forth. Okay, but here we have the same also with the process of naming it. So we have those zero function up to the nth degree of polynomial function, representing the degree, the leading coefficient, the constant term. So, okay, so it's just a matter of given example, and then what is the degree, what's the leading coefficient, constant term. So with the given, it's very self-explanatory of getting the degree, the leading coefficient, and the constant term. Okay. Rational series of polynomial function, of course, is just like the zero product property. Let's have the fundamental theorem of algebra. What is that all about? For every polynomial function whose defining equation is f of x is equal to a sub n x to the n up to a sub 0, where a sub n is not equal to 0 and n is greater than or equal to 1. That could be the restriction, at least one complex 0. Okay, it means that whatever the degree of the polynomial equation or the polynomial function, that could be also the number of, or the utmost number of roots and zeros. Because in equation, so specifically we call the answer in equation as roots, but in function sometimes, or we interchange calling the answers as roots and zeros. How are we going to differentiate the answers in functions and equations? Sometimes there are some restrictions. So in equation, we call the answers as roots. But in functions, we call the answers as what? Zeros of the function. Why is it called zeros of the function? Any idea, Rodel?
Sir, ako po ba?
Yes, any idea why is it called the answers in function as zeros of the function? Anong essence nun?
I bet, sir, it's basically because that they are the values that would make y equals 0. Kaya sila
Precisely.
tinatawag na
Kaya tinawag na
zero.
zeros of the function. So, ganun lang. Di ko alam kung lahat yun naintindihan ng kaklase mo. Cervantes, do you have the same understanding of what Rodel discussed and what Rodel sharing? Cervantes?
Yes po.
Yes. Oh, it's just a matter that you're so quiet. That all of you are so quiet. Okay, so maybe we will have problem. We will have to go directly. I will just discuss it. So it means that you do understand. Okay. So it's a fundamental theorem of algebra. Just check with the higher degree of the polynomial function or equation. That could be the highest or the utmost possible roots or zeros also. Okay. And then, okay, if we there's a repetition with regards to the roots and the zeros, instead of two times, three times, that answer appears. So we'll use multiplicity. So multiplicity, say for example, we have 3, negative 3. So negative 3, 3 times. But instead of using 3 times, you have to use negative 3 multiplicity of 3. If we have 4 negative 3, we have to use negative 3 multiplicity of 4. I hope you do understand the word of multiplicity, zero of multiplicity, because that is very important in plotting the graph of the polynomial functions. Okay, so let's have the example here. Okay, find the zeros of the given function, determine the multiplicity of each zero. Of course, okay. What is the name of the given function? Since you don't need, you're not answering my question, I will be the one to give the answers to my question. I'm going to ask myself and I'm going to answer by myself,
Wait.
so that Rudilk and I will not having a hard time of have discussing anything here. So it seems that we're just the one participating in this class, so it's okay. I don't know what are the reasons why you're not participating, you're not opening your camera. Maybe you're doing things, but I'm still giving you chances to show your face. But if you don't want to show your face, it's up to you. If you don't need my discussion anymore, so we can stop it right here, and then you can proceed to LMS. Is that okay? What could be the case? Okay, so sad to say, but I don't need to compare all these three SSC. But I always record all your participations and all your synchronous class, and I'm submitting it to our head, and our head will be assessing what is happening for every SSC. Okay, so since I already stated my quiz, so function of x is equal to the quantity of x plus 1 cubed times the quantity of x minus 1. If I'm going to ask myself what could be the name of the function, I could say that the name of the function is quartic function. Why? Because the highest degree is 4. If we're going to multiply x cubed by x, it gave us x to the fourth power. Therefore, the name of that function is what we call quartic function. And then, since I already identify with the given type of function, I can now assess how many zeros of the function I can get. So since the highest degree is 4, therefore, I can get 4 zeros of the function. That could be the values of x, where could y could be equal to 0. And how we're going to do that? Since the question is find the zeros of the given function and determine the multiplicity of each zero, all I have to do is to equate all the given factored form to 0. And then let's have x plus 1 is equal to 0. That is negative 1. And how many negative 1? So we have 3 negative 1. Instead of using 3 times, I'm going to use negative 1 multiplicity of 3. And the other one, x minus 1 is equal to 0. The value of x is equal to 1. Therefore, I have 3 negative 1. I have 1 positive 1. All in all, I have 4 zeros of the function. Therefore, fundamental theorem of algebra is correct. Okay, and this is the answer. And let's proceed to example number 2, Rudil. Yes, Rudil?
Okay.
Okay.
What should I do?
No, no, no. Just listen and just look at me so that I have a student looking at me while I'm discussing things, huh? Okay, that is a good participation. Okay, so we can do nothing but to face the reality of the scenario of having an online class. It's good thing that I'm not really applying my rules in online class, because last time I already gave my statement, and I know that your comprehension is not that low, and you do understand what I mean every time we have a synchronous class. But sad to say, there are students, it seems that they didn't know any rules and regulations with regards to online class. Maybe you can discuss that Cervantes as a president of then Galileo. And I don't want to be disappointed by your section because of not doing the protocols and the rules and regulation whenever we have our synchronous class. So whatever the reason may be, I'm always asking the president and all the sections that I'm handling in online class, if you cannot open your camera, if you cannot open your microphone, just state your reason, give it to your president, and then forward it to the teacher so that I will have an idea what is going on during the synchronous class. Do not just say that in during the discussions. Okay? So nevertheless, so again, for the question, how many zeros do I have here? So I'm going to check first what type of polynomial function is this. Since the degree of the polynomial function is equal to 6. So therefore, it's a 6-degree polynomial functions. And how many zeros I can get? Of course, by the rules of fundamental theorem of algebra, I can say that I can have 6 zeros, but not greater than 6, but it could be less than. There are cases that it could have a real or not real zeros or imaginaries. But all in all, applying the fundamental theorem of algebra, we can say that we can get 6 zeros here because the degree of the given polynomial is 6 degree. And therefore, so if we're going to equate all the factors to 0, that is x minus 1 is equal to 0, that is x is equal to 1, how many positive 1? We have 2. And then x plus 3 is equal to negative 3. And then how many negative 3? It's 3. And then x minus 2 is equal to 0, that is x is equal to 2. How many 2? We had just 1. So all in all, we have positive 1, multiplicity of 2. We have negative 3, multiplicity of 3. And we have positive 2, multiplicity of 1. So that's the answer. Okay? So finding the zeros of the given polynomial function. Okay? So I'm not going to answer it anymore since I'm going to check what type of polynomial function is this. So the exponent is 5 plus 4 plus 1 plus 1e. We have 11. So 11th degree polynomial function. So therefore, applying the fundamental theorem of algebra, so I can have 11 zeros of the function. It means that the graph will pass the rectangular coordinate system in x-axis 11 times, right? Okay, that is the meaning of the zeros of the function. Okay, let us proceed to the next topic, which is the Descartes rule of sign. Descartes rule of sign, a function of x is equal to a sub n x to the n power. So all you have to do is to check the number of variation. What do you mean of the number of variation? If there's any changing sign of every term, that's what we call variation. So just check all the sign of all the term. The number of variation is equal to the number of possible positive zeros, right? And then if you want to get the negative zeros of the given polynomial functions, all you have to do is to replace the positive x to negative x. And whatever the number of variation, therefore, that could be also the number of the negative zeros. Let us apply. But not all the time because there are cases of just an imaginary. All you have to do is subtract the by its even number. Okay? That's the rule of the. So what I'm discussing right now is the way you're going to discuss it on your final requirement. So maybe if you have 3 learning tasks, 4 learning tasks, I will just omit 3 learning tasks to equate all that requirement. So maybe in the last part of your second quarter, so instead of doing 4 learning tasks, I'm going to replace it. So you just have, maybe you cannot do the 4 learning tasks or just having 1 learning task, and then the other 3 is equivalent to your final requirements, which is having the music or the video of your presentation. You are the one explaining and applying the fundamental theorem of algebra, Descartes rule of sign, and the rational root theorem. Okay, so since we already applied the fundamental theorem of algebra and the multiplicity in the polynomial function, let us now apply the Descartes rule of sign. Of course, Descartes rule of sign is the one who is the main personality or the mathematician who
Rene
discovered
Descartes.
the rectangular coordinate system, right?
Rene Descartes.
Si Descartes. The other, they call it Descartes rule of sign. Okay? So, let us apply number 1. Okay. Determine the maximum number of positive roots and the maximum number of negative roots of the given polynomial function. Since polynomial function, we can interchange that by roots and zeros. Okay. All you have to do is to count the number of variation. So do we have number of variation? It's positive and positive. So we don't have any changes because it's all the same positive, and then positive to positive, we don't have any changes at all, and then positive to positive, we don't have any changes. Because we don't have any changes, therefore we don't have positive zeros of the function. That is the Descartes rule of sign. Understood? And then if you want to check how many negative, of course, possibility, if okay, if we don't have any positive zeros, therefore possible that all the roots are negative. And how many roots do we have and how many zeros do we have? It's 3 because the degree of the given is third degree. That's why the possible number of your zeros is equal to 3. Okay, so that is the answer. So changing it to negative. So there is a 3 variation. So that's why we will have 3 negative. There are 3 variations of sign in function f. There are 3 negative roots. Therefore, all 3 roots of the functions are negative, or zeros of the functions are negative. Okay? So let's have another example. Almost the same. Okay. So how many positive? How many changes? We don't have. And then this one. And then, okay. It means that we just have one positive. And the other one is, the other two is negative. One positive zeros and the other two is negative. Okay. Changing it to negative x. So therefore, there are one positive and two negative roots of the given function. Okay. So let us proceed. Okay. Before, it's a rational root theorem. But we can have this rational zero theorem. Of course, it's still the same. I already discussed that to you last time. All you have to do is to check the constant and get the factors of the constant and then divide it by the factors of the leading coefficient. So whatever the result, those are the possible zeros of the given polynomial functions. Okay? Just like here, our constant is 1. Therefore, the possible zeros is negative 1 and positive 1. So it's just a matter of identifying how many positive 1 and how many negative 1. But applying the rational root theorem or the rational zero theorem by getting the factors of our constant, which is positive 1, dividing it by the leading coefficient, which is also 1. Therefore, possibility of our values of our zeros is negative 1 and positive 1. And since the degree of the given polynomial function is third degree, therefore, we have 3 zeros of the functions, and these are the answers. Okay, and then we can still use the if you want to use the synthetic, so that's it. Synthetic division, negative 1 as your synthetic divisor, and then we arrive with 0. Therefore negative 1 is one of the factors or one of the solution, and then that is already in quadratic form. You can factor it out. Okay, so instead of x squared plus 2x, we can factor it by this one. So if you want to still continue with the synthetic division, we can still use negative 1 and then the coefficient of x squared 2x plus 1, and then we will arrive also with the 0. Therefore, how many negative 1 do we have? Dalawa na. Okay? So all in all, we have 3 negative 1. The zeros are negative 1 multiplicity of 3. Okay? Okay? So let us proceed. That is the rational root theorem. Okay. Here is your output in the Google Classroom. So I will just post it to your FB group. Oh, I don't need to discuss it anymore because it's already given to you last time with regards to different kind of inequalities, how to graph, how to represent interval, inequality notation, set notation, interval graphical representations. So you have all the ideas about that last grade 7 and grade 8. So I don't need to have more explanation of that. But I included that in my PowerPoint so that if forget something, so you can still remember. Okay, but our main focus is to graph the polynomial function. How are we going to graph the polynomial function? Okay, if we're going to have this destiny of my behavior, so we have the values of x and then we have the values of y, and then the relationship of y value to 0. So since we cannot have that one by one, I will give you the answers already. If the value of x is negative 5, the value of y is 144 with that given. Because the given is y is equal to x times x plus 4 times x plus 2 times x minus 1 times x minus 3. That's the given. All you have to do is substitute the values of x here and then you can arrive with the values of y. And this is the summary. The value of y is negative 5, 144. Therefore, what is the relationship of the value of y? Y is greater than 0. Therefore, that is above x-axis. And then if the value of y is negative 4, the value of y is 0. Therefore, y is equal to 0. That is on the axis. And if the value of x is negative 3, the value of y is negative 24. That is less than 0. Therefore, it's below the x-axis. Okay? So on and so forth. So let us answer at what point does the graph pass through the x-axis? So of course the answers, what are the values of x that could make the values of y is equal to 0? Therefore, there are negative 4, negative 2, positive 1, and 3. Those are the values of x that could make y is equal to 0, right? So according to the table. And then the second question, if x is less than negative 4, what can you say about the graph? Of course, that's already in the fourth column, the graph is above the x-axis if the values of x is less than the negative 4. And then if the values of x is greater than negative 4 but less than negative 2, what can you say about the graph? Still the same. The graph is below the x-axis. That is the purpose of that. Okay? That is the answer. Now, this table may be transformed into a simpler one that will instantly help you to locating the curve. We call this table of signs. This is your assignment in Google Classroom. You will do your own table of signs. The roots of the polynomial functions given are negative 4, negative 2, positive 1, and positive 3. These are the only values of x where the graph will cross the x-axis. In Tagalog, yun lang yung mga value na x kung saan dadaan ang graph natin at magiging 0 ang y. Okay. This root partition the number lines into interval. So, because of that passing, so yung mga point na yon, the point where the graph passing the x-axis, we can have that partition. Just like boundaries in your inequalities. If you still remember the graphing of your inequalities, that's what we call boundaries. And sometimes we use test point or test value in order to identify if the boundaries are really included in the solution or not. If they are included, we have to shade it. If they are not included, we don't need to shade it. That is the quadratic inequality. I hope you do that last year, Rodil. The quadratic inequality. You have the graphing of.
Yes po.
Okay, so we don't have any problem. Okay, instead of partition, so we're going to use intervals. So since we have how many partitions? For every degree of a polynomial functions, in order to identify how many partitions do we have, all you have to do is to just add 1 to the degree. If the degree is 4 plus 1, we have 5 partitions. And then we call that partition as interval. Okay? And then this is the exact, okay, of our table of signs here. Okay? That's a table of signs. All you have to do is to have that column. Why do we have 5 columns? Because the degree is 4. So we just need to add 1 in order to locate the division. And then all you have to do is to get first the zeros of the function in order for you what could be the first factor. Since negative 4 is the lowest, so negative 4 plus 4 is the first factor, plus 2, negative minus 1, minus 3. And those are the factors of the given. All you have to do is to have this interval. With the first interval, of course, the values of x must be less than on that factor. If you're going to equate x plus 4, that is negative 4. That's why the values of x here in the first interval is less than 4. And then, of course, with the second negative 4, what is x? Next is positive 2. Therefore, it's between negative 4 and negative 2. And then between negative 2 and positive 1. Between positive 1 and positive 3. And the last one is x must be greater than 3 or positive infinity. And then the left side is negative infinity. Okay? And then all you have to do is to, if you already locate those intervals, all you have to do is to have the test value. For every interval, we will have the test value. Say, for example, that since x is less than negative 4, so all the numbers less than negative 4, we can use it. And let us try negative 4. Negative 5 is less than negative 4. We can use this. Negative 5 substituted to x, that is negative 5 plus 4, negative 1. That's why the sign here is negative. Try to remember that. And then next one, negative 5 plus 2, that is negative 3. That's called negative. The sign, just look with the sign in order for us to know the location of our interval. And then negative 3, ay negative 5 minus 1 is negative 6. So it's still negative. And then negative 5, negative 3, negative 8. All negative. In order to get this sign, all you have to do is multiply. Negative times negative is positive, times negative is negative, times negative positive. If that is positive, therefore, the position of your curve is above the x-axis. And then same with this interval. So in between negative 4 and negative 2, we can use negative 3. Substitute it to the given factors, and then we have positive because negative 3 plus 4 is positive 1. Then negative 3 plus 2 is negative 1. And then that's why it's negative. And then multiply it again. Positive times negative is negative. Times negative is positive. Times negative, negative. It means it's below. The curve is below the x-axis. So on and so forth until we reach the fifth interval. And then we can graph the polynomial function now. Okay? So these are the intervals. Okay, the first interval, yeah, that's it. The first interval, the second, the third, okay, so on and not this one also lang. Hindi kasama tong isa. Kasi hindi naman siya dumaan sa x. Okay? But the number of intervals, so here, and then yan, hindi ko makadiretso ng guhit. Ayan. Okay, 1, 2, 3, 4, 5. Okay, the curve here. So it means that if x is less than negative 4, so the curve is above the x-axis. And this is below, above, this below again, and then above. Okay, so that is the process. And then let's have one example. Okay, one example of this. So, nauna na yung given bago yung solution. Okay? So with this example, another example is the graph of function of x, negative x, x plus 2, x plus 3. Okay? Here are the intervals, and then table of signs, and then that is the graph. That's one way. But we have another way of graphing the polynomial function. Yan is another example. So your assignment, you have to choose between 2, 3, 4, and 5. Just choose one and then do it. Let's have number 1 here. One example. The number of x-intercept, the interval of the x-intercept, the table of signs, and sketch the graph. So ito yon. So intercepts are the values of x, where y could be equal to 0, right? That's why it's called intercept. We have to make y is equal to 0, right? Okay. So let's have the graph of polynomial function another way around. So we have step by step, write the function in the factored form, and then find the end behavior of the leading coefficient test. All you have to do is to check the leading coefficient test. What is that leading coefficient test? Okay, we have 4 cases for the leading coefficient test. If the exponent or the degree of the polynomial function is odd number, and then the leading coefficient is positive. Therefore, it will fall to case number 1. What must be the behavior? We are explaining this the end behavior of the graph. If the case is the degree of the given polynomial function is odd and the sign of the leading coefficient is positive, therefore it falls to the left and rises to the right. That could be the behavior of the graph or the end behavior of the graph. That is case number 1. If we have case number two, the still the degree of the polynomial function is odd and then the leading coefficient is negative. Therefore, if that is the case, that the behavior of the graph is rises to the left and falls to the right. And then we have case number 3. If the degree of the polynomial is even and the leading coefficient is positive, therefore both ends on right and left rises. So it's rises to the left, rises to the right. That is case number 3. And then let's have case number 4. If the degree of the polynomial is even and the leading coefficient is negative, it both falls to the left, falls to the right. So we have cases 1 and 2 if the given is odd number. If the given degree is even, we have case 3 and 4 as our choices. The only thing that we're going to check is the sign of the leading coefficient. If the sign of the leading coefficient and if the degree is odd and the sign is positive, that's case number 1. If the degree is odd and then the leading coefficient is negative, that's case number 2. That was number 3. If the leading coefficient is even and the leading coefficient is positive, that's case number 3. And then if the degree of the polynomial is even and the leading coefficient is negative, that is case number 4. And then we have this multiplicity. How are we going to graph the multiplicity? This is the way we're going to graph the multiplicity. Check the multiplicity. If the multiplicity is even, it just touches the x-axis or the point, but it didn't cross through thoroughly. Okay? And if the multiplicity is odd, therefore it goes to different directions. Okay? So that's the meaning. That's why there's a purpose of your multiplicity. If that is odd, it just touches the x-axis. If that is odd, if that is even, it just touches. If that is odd, it will cross the x-axis. Okay, let us. And then, of course, the step 3 is having the table of values, then plot the point, and then the graph. Okay, let us have this. The given is x cubed minus 2x squared minus 3x. Let us first step, factor it out. So the factors are x times x minus 3 times x plus 1. And then the zeros are 0, positive 3, and negative 1. And then what case is this? Since the degree is odd and then the leading coefficient is positive, therefore it's case number 1. It falls to the left, rises to the right. That's the behavior. Okay? Falls to the left, rises to the right. Then, next one. What is the degree? It's still 5. 5 is the fifth degree. Therefore, it's case number 1 because x is still positive. Falls to the left, rises to the right. That's the multiplicity. It means the multiplicity is even because it goes directly. It just touches the x-axis. This one is a multiplicity which is odd. Therefore, it crosses the x-axis. Okay? And then this one, of course, that's a parabola, right? That is case number 3 because the degree is even and then the leading coefficient is positive. Both rises to the right. Okay? And then this is odd. And then positive, the value of the leading coefficient is positive. Therefore, it's case number 1. Falls to the left, rises to the right. Same with this, same given. And then this one, okay, still cube, positive, falls to the left, rises to the right. This one is even, okay, even, and then positive, that is rises to the left, rises to the right. So that ends my discussion with regards to the graphing of the polynomial functions. And I'm going to just to post it to your FB group so that if you want to browse, if you want to understand more with regards to the discussion, it's up to you. But there are still resources in our LMS and there are some resources. I gave you already the soft copy of your book. All the things that I'm discussing right now and I've discussed right now is in your Learner's Manual Grade 10. I gave you the soft copy. If you want to have more exercises of the polynomial function, you can have it by downloading your soft copy of your learner's manual for grade 10 mathematics. That could be all. So just see you with regards to your LMS. So I'm just waiting for your score, and we already have okay exactly 1 minute because I started at 8:02. Exactly 1 hour of discussion. And of course, next week, tomorrow is the time for us to uh, give your grading sheet, the grade for first quarter. That's why I open the LMS. Could you imagine how many times I gave extension? So almost twice. I gave extension twice. So from week 1 up to week number 8. What's the meaning of that? I'm giving extension in order for all those students who still have lacking learning task, they can complete it. And those who doesn't have any learning task from week 1 up to week 8, they can still do it. But if they didn't do anything, I can do nothing but to reflect their grade. But if their grade could be line of 7 or possibility of failing, I will just inform your advisor so that your advisor will have a dialogue with your parent. So before giving the grade tomorrow. Okay? That could be all, Cervantes. I know you do I already have my point. Always remind your classmates from our synchronous class. Do you know what I mean, Cervantes?
Opo, sir.
Okay, I hope that this is very frustrating. I just want to teach you from face to face so that we discuss things and we can have the discussions, but it's still up to the student, whether it's online. And I'm really assuming that all of you really get what I'm discussing, and then some of you already have the advanced learning. So it doesn't necessarily mean that if you didn't open your camera or if you're not responding, you don't know anything. I'm just accepting the fact that's the reality bites. That the reality bites that in online class we have this kind of scenario. But Cervantes always remind them because I'm always asking you who are the students who keep open their camera. It's just always Rodil. But it's sad to say that it's just Rodil just keep opening his camera. And your classmates didn't give any reason why they cannot open their camera. Okay, Cervantes, is that clear to you?
Opo, sir.
Okay, as a president, I'm really passing the ball to you to handle your section during our synchronous class. And I hope during the second meeting of our synchronous class, I will experience the different grade 10 Galileo. But if you want to have that impression to me in mathematics, it's okay. But if your classmate has that change, wants that changes, it's okay. Not for me, but for you to be disciplined and for you to comply what must be the requirement in an online class. Okay? So that's all for today. So I can do nothing but to say goodbye. God bless, and I hope that you really learn things with my discussion. And then you all have all the resources. Our time is very limited. Okay? That's all for today. Goodbye, class.
Bye po, sir. Thank you
Thank
po.
you
Okay,
po,
bye-bye.
sir.
Bye po, sir. Sorry po, sir.
It's okay, no problem.